Okay, covalent compound drawing. All right. So number 1 on this page will be this, CS2. Let me just look through in the camera real quick, make sure it's... Okay, good, you see it. All right. So first things first, you should know the difference between an ionic and a covalent compound. But to make sure, you want to make sure you write non-metal, non-metal, because now the strategy is we're going to show how we share electrons. Okay, so let's take inventory. So the first thing you do, but see, you have to understand the periodic table first, and we've learned that to be able to do this, because everything builds. So carbon is group 14, 4 valence electrons, wants to gain 4, and I'm going to come back to that in a second. Sulfur we know is in group 16, it's got 6 valence electrons and wants to gain 2. Okay, now, so because it wants to gain 4, it needs to form 4 covalent bonds, 4 shared pairs. So whatever I gain is how many covalent bonds I need to form. Here, whatever I gain, right, I want to gain 2, I need to form 2 covalent bonds. Now, we've talked a little bit about in class, how do we show covalent bonds with a line? So here's a little simple thing I added. If I have 4 covalent bonds, that means I need to draw 4 lines. And if I need 2 covalent bonds, I need to draw 2 lines around each one. And there's 2 of them, so let's watch. So carbon is always in the center because it's got 4 spots usually, right, to accommodate different combinations of atoms. I'm going to put carbon there. Now how many sulfurs do we have? 2. So I'm going to put 1 on this side and 1 on this side. And now you go back. How many lines, how many covalent bonds does carbon form? 4. So how many shared pairs of electrons, aka lines? 4. And each sulfur needs 2. So carbon almost like distributes the bonds. So we're gonna, this guy needs 4. Each one of these needs 2. So watch this. So in class we drew like the dots and the X's to show how these work. But what do you notice? Carbon has 4 lines around it. So 4 lines equals 8 electrons. It's got a full outer shell. Sulfur, on the other hand, has 6 valence electrons already. Each one has 6 already. So that's to share 2 pairs. That's why we have 2 lines. So a lot of kids leave it like this, but they got to remember to check for the what we call the octet rule in challenge science, full outer shell. So let's check. 2, 4, 6, 8 carbon is good. Each one needs 2 lines. We did a great job, but if you leave it like that, it's wrong. You have to show the full outer shell. 2, 4, 6, 8. 2, 4. That's great, but you got a full outer shell. 6, 8. Why? Because they had 6 already. 1, 2, 3, 4, and then this one they share is 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's the structure for carbon disulfide. Now, if you're in challenge science, you would know that that is a nonpolar molecule because the two polar bonds cancel out on both sides of the molecule. So that's challenge science. That's nonpolar. But any kid, you need to know how to draw these. Okay? So that's the first one. Let's take a look at the second one. CH2, Br2. Notice a lot of these have carbon, again, because they're very versatile. They can bond with different things because they have 4 valence electrons and 4 openings. So these are all non-metal, 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 whatever. Take inventory. Group 14. Now I'm not going to go all the way down for every one of these. Eventually I'm going to speed up a little bit. Group 14, 4 valence electrons. Gain 4. Needs to share 4 pairs of electrons, 4 covalent bonds. That means how many lines do we always have to draw around carbon? 4 lines. Okay? I have 2 hydrogens. They're group 1. Now, what do they need to do to get a full outer shell? Gain 1, because they're in period 1. They have that small level which has 2 electrons, so they need to gain 1. So they have 1 valence electron each. They need to gain 1. So whatever you gain is how many covalent bonds. So it's 1 covalent bond. 1 line each. Bromine, I have 2 of them. Group 17, halogen, 7 valence electrons, right? They need to gain 1. They need 1 covalent bond. So therefore, for them, you draw one line each. So again, what always goes in the center? Carbon. And how many bonds does that have to form? 4. So 4 lines, 4 shared pairs of electrons. So before you, what's this? How many hydrogens? You have 2. 2 lines total. How many bromines? 2. 2 lines total. This is easy. 2 and 2 gives you 4. So you put carbon in the middle. Now, I'm not going to worry about where you put the bromines and hydrogens right now. I'm going to put it this way. Even in challenge science, doing everything with the polarity, we'll get in discussion in class. So right here, I put carbon in the middle. Each hydrogen, I'll put them over here. How many lines do I need around carbon? 4. I have 4 spots. 1, 2, 3, 4. I'll put hydrogen here. I'll put hydrogen here. So that guy's taken care of. That's taken care of. What about the 2 bromines? 2 spots. So let's check. 2, right? 1 line for hydrogen. That's good. Why? Because it's 2 electrons, valence electrons, full outer shell. 2, that's good for hydrogen, full outer shell. Carbon, 2, 4, 6, 8, 4 lines. Is this right? Wait a minute. The lines look good. Bromine each needs 1 line. But watch, 2. Oh, you have to show the excess valence, because remember that's 7. So here's 6, and the 7th is right here, sharing with the 8. So it's 2, 4, 6, 8. 2, 4, 6, 8. See how that works? That's how you draw it. Okay? So again, take inventory of what you have. However many covalent bonds you need is how many lines you're going to need to form around that. But a lot of kids do forget, once I set this up, I'm done. No, you have to show prove full outer shell. 2 is a full outer shell for hydrogen. 8 is a full outer shell for carbon. Bromine, a lot of kids forget, draw the excess valence. And again, you people in challenge science, very important to determine polarity before we get into electronegativity difference. Okay, that's that. Let's take a look at this, H2S. It's just like H2O because they're in the same family. Sulfur and oxygen. So right here, now I'm going to go a little faster with our inventory. Hydrogen, group 1, 1 valence electron, needs to gain 1, right? That means 1 covalent bond, 1 line each. Sulfur, group 16, 6 valence electrons, gain 2. So whatever I need to gain, that's how many covalent bonds I need to form. So I need to make sure I have, look here. Look here. He needs to gain 2. Why am I having a brain fart right now? I'm not going to edit the video. Hold on. Okay, we're good. Needs to gain 2. It has 2 covalent bonds. Okay? So again, you need to have 2 lines around it. Alright, now. So let's take a look for a minute. Each hydrogen needs 1 line. So we're going to put sulfur in the middle. Now, water, just like this, is bent. Now, if you're in traditional science, you draw it straight across, that's fine. I'm going to show it bent for challenge. So how many lines do I have to draw around sulfur? 2. 1, 2. Now, hold on a minute. How many lines does each hydrogen need? 1. There's its line. 1 bond. 1 shared pair. Here's its bond. Now check it. 2 full octet or full duet. Excuse me, duet for hydrogen. Good. 2. Good. Sulfur. It's got 2 covalent bonds. It's done. No, it's not. All you're showing me now is, right, the 2 that it shared to get 4. So again, 2, 4, 6, 8. Check it. That's how it should be. For challenge science, given this shape, it would be polar, traditional relaxed. All you need to know is how to draw it. Okay? Any questions on that? Write it down. All right. I'm going to save C8H18 for a little bit. That's an easy. It's easy, but I want to wait. I like that one. CO2. These are all covalent, so non-metal, non-metal. Carbon, 4 valence electrons, gain 4, 4 covalent bonds, 4 lines. Now I got 2 oxygens. They have 6 valence electrons. They need to gain 2. So they have 2 covalent bonds each, right? Because here, I'll write this down. Gain 4, 4 covalent bonds, 4 lines. Gain 2, they need to have 2 shared pairs of electrons. So 2 lines each. Easy. What always goes in the center? Carbon. How many lines do you need? 4. But wait a minute, look what you're working with. 2 oxygens, they each need 2. 2 plus 2 is 4. Look how perfect this is. Carbon, 2, 4, 6, 8. We fulfilled the octet rule, full outer shell. Oxygen, needed 2 lines, 2 covalent bonds. 2, 4, 6, 8. Make sure you draw those excess valence. Oxygen, 2, 4, 6, 8. Done. Now you people in challenge science, non-polar molecule, we have 2 polar bonds because the electronegativity difference is greater than 0.4. So again, even though we've got 2 polar bonds, right, traditional relaxers, let me speak for a minute. I know it's for you too, but this part no. It's a non-polar molecule. Okay, that's why it's a gas at room temperature, forms very weak IMFs, and so on and so forth. Okay, so again, 2 polar bonds gives you a non-polar molecule. Gas at room temperature, weak IMFs, that's why. But again, the key I need you to know out of this video is how to draw covalent compounds. Okay, easy. Okay, let's do NCl3. Okay, NCl3, let's put this here. Nitrogen group 15, right? 5 valence electrons, gain 3 covalent bonds because of that. Has to share 3 pairs. Therefore, it needs to draw 3 lines. Each chlorine is group 17, 7 valence electrons, halogen group, gain 1 covalent bond each for a total of what? 3. So 1 line each for a total of 3. So nitrogen goes in the center, right here. How many lines around nitrogen? 3. 1, 2, 3. How many chlorines we got? And they each need what? 1. Again, kids, stop there. No, you won't. Check it. Start with nitrogen. 3 lines. That's all you're supposed to do. 2, 4, 6, 8. Chlorine. 2. Oh boy. 4, 6, 8. Chlorine. 2, 4, 6, 8. Here. 2, 4, 6, 8. Okay. Traditional, that's how you draw it. Now, challenge. Tell me about these 2 ends. They cancel out. These are 2 polar bonds. Alright? So when we look at the symmetrical aspect of the molecule, this is nonpolar. They're both negatively charged, they cancel out. But is this molecule polar? Yes, because there's a greater electronegativity difference towards this end. Chlorine is very electronegative. So is nitrogen, but overall the electronegativity difference is greater than 0.4. This is a polar bond. We don't have another chlorine up here. Therefore, this is a polar molecule. This can dissolve in water. Remember, polar likes polar, okay? So there's a little bit of an IMF that could occur right here, albeit somewhat weak, not as strong, somewhat strong, similar to a hydrogen bond, but overall, polar molecule can dissolve in polar substances, okay? All right. I'm trying to, cover both classes in one video to be efficient. All right, let's take a look at this one. CH3OH. Okay, I like this one. Go left to right. Now I'm going to go a little fast because we've seen these elements before, these atoms. 4 valence electrons, 4 covalent bonds because it wants to gain 4. 4 lines, always in the center. 1 valence electron, 1 covalent bond, 1 line each. Right? 6 valence electrons, oxygen. Right? 2 needs to gain 2. Gain 2. 2 covalent bonds, 2 lines each. Now this hydrogen goes with that oxygen because challenge science, OH is a functional group called a hydroxyl. It demonstrates that this is an alcohol. It's called methanol. So therefore when you have an OH hydroxyl group, it's on one end of the molecule. So right here we got hydrogen, 1 valence electron, 1 covalent bond, 1 line. Okay, so now we have our recipe. Now let's cook. Carbon in the middle. So watch, 4 lines. 1, 2, 3, 4. Here's the nice part. That's taken care of. Look at the hydrogen. I have 3 of them. 1, 2, 3. That's taken care of. Well, what do I put here? Oh, right there. Now stop for a second. Check here. 2, 2, 2. We filled the 2 outer shell for hydrogen. The duet rule. Good, good, good. Carbon. 2, 4, 6, 8. That's good. Oxygen 2, but wait a minute. You need 2 covalent bonds, 2 lines. Well, I'm glad a hydrogen is here. So I need to draw what? One more. Where am I going to get that second line? Right here. What do I put right there? H. So the 1 line for hydrogen is taken care of here. The 2 lines for oxygen is right here, the 2 bonds. Now we check these guys over here. This is good, this is good, this is good, this is good. Check your problem. 2, good. Now some kids will just draw this for oxygen to make sure it has a full outer shell. Well, you just gave 2, 4, 6, 8, 10 to carbon and 4 to hydrogen. No. It already had 6. So it's 2, 4, 6, 8. That's how it looks. Now everything is checked. Challenge science. Barely polar bond, barely polar bond, barely polar bond, polar bond, polar bond, barely. Actually, it's polar bond. But where's the polarity? Towards this end of the molecule. This is polar. This will dissolve in water. Methanol will dissolve in water. It's barely polar towards this direction because of the highly electronegative oxygen, which is next to the most electronegative atom on the periodic table, fluorine. Why is it the most electronegative, being fluorine? Because it has a small atomic radius, okay, due to the fact that it wants to gain valence electrons, and it can draw that electron in because it has the smallest atomic radius, therefore the greatest force of attraction. Again, I'm trying to help both classes here. All right, so we got that taken care of. Okay, you all see that? 2 more. C2H4. Okay. 4 covalent bonds because it wants to gain 4. Right? 4 lines. C2H4. Each one has 1 covalent bond. They want to gain 1. 1 line each. So when you see this, always put your carbons in the center. Carbon, carbon. Now you have 4 hydrogens. You have to evenly distribute them. So I'm going to put it like this. Now in high school you're going to do like this, where it's diagonal and all that. You'll get to that. Honors chem, it's called Vesiper. You'll do that in high school. We'll do it like this for now. 1, 2, 3, 4. So watch this. 2, good, 2, good, 2, good, 2, good. So these guys are good. Now what about the carbon? We need 4 lines around it. Carbon only has 2. This one only has 2. Double bond. So 2, 4, 6, 8, he's good. 2, 4, 6, 8, that one's good. Okay? And you don't need any excess valence electrons. We fulfill the octet rule of 8 outer shell full for carbon. We fulfilled the duet rule of 2 for hydrogen. Because again, first period, 2 valence electrons in that first shell. Okay? Last one. Octane. Okay. Ooh, it looks scary. Okay, watch this. Draw 8 carbons. When you have something like that, this is called a hydrocarbon chain. You guys in challenge, you know it's a hydrocarbon. You know this is a nonpolar molecule. You know it has a very high bond energy. You know it when it does combust, it causes a big explosion. So now each one of these has to have 4 lines around it, right? 4 covalent bonds, right? Each one of these needs 1 line. Well, can I tell you something? Watch this. How many lines are on each carbon? 8. I'm sorry. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Well, how many hydrogens do we need to draw? Watch this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, get out of the way, 16, 17, 18, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, good. 2, 4, 6, 8, 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 good. There you go. So again, challenge science, Even though these bonds are barely polar because they have an electronegativity difference of about 0.4.
Please excuse interruption.
No.
Madison Peck.
Alright, so they have an electronegativity difference of 0.4.
Engro, Grace Wilding, Jenna Briggs, Gianna Graziano.
Alright. There we go. That's it for the video. Do your work. You're doing a great job. Alright, thank you. Bye-bye.